Introducing related rates now. One of the most difficult topics you're going to have to deal with derivatives. And here's the list of steps. It's in the next section. We got to draw a picture sometimes. Write down the known information. Also write down what you're looking for. Write an equation. So this first section is kind of going through step by step through those things. So we're going to start with identifying what information do we have and what information are we looking for, such as not given is probably what we're going to be looking for. So let's read through this problem and go ahead and figure out what it's giving us. So the height of a rectangle is increasing at a rate of 11 centimeters per hour, and the width of the rectangle is decreasing at a rate of 9 centimeters per hour. At a certain instant t0 or t0, the height is 3 centimeters and the width is 8 centimeters. What is the rate of change of the area A of t of the rectangle at that instant? So at that instant, so what is the rate of change? So let's start with this. The height of a rectangle is increasing at a rate of 11. So is this telling us that the height is 11 or that h prime is 11? Well, it says that h is increasing at a rate of 11. So that's actually saying that h prime of t is 11. The derivative is 11. The rate is 11. So it doesn't matter the t value. This rate will stay the same. So h of t not, well, that's actually not given. Let's see. I don't see that anywhere in here. Or you can see, look at this notation. They're using dw dt. So I guess we could call that dh dt. Our derivative is 11. Just to stick with that notation, makes sense. It also tells us that the width of the rectangle is decreasing. Now that's a negative rate. So the width is decreasing at a rate of 9. So that's telling us that dw dt is negative 9. It's decreasing. So we're going to go ahead and cross that off. At a certain instant t0 or t0, the height is 3 centimeters and the width is 8 centimeters. Okay, h of t represents the height. So this is telling us when t is 3, or when at a certain moment of time at t0, our height is 3. So what that means is that h at t0 at that time, the height at that time, whatever time t0 is 3. So that's given, that's there. What is the rate of change of the area A of t? So it's not asking for A of t, it's asking for the rate. So what do we do about that? The rate of change of A of t at that instant. Remember that instant is t0. So that would be A prime of t0. It's asking for that. So we don't know that. We're going to find it. So you got to establish what's been given here. What's been, and what are we looking for? So what's been given, what are we looking for? So you just decipher those things. Let's look at another one of these. The radius r of t of the base of a cylinder is increasing at a rate of 1 meter per hour, and the height of the cylinder is decreasing at a rate of 4 meters per hour. So this is telling us that dr dt is increasing at a rate of 1, and that dh dt, the height, is decreasing at a rate of 4 meters per hour. At a certain time, we don't know that time, the base radius is 5, so at a certain time r is 5, and the height is 8. So that's the actual height, not the change in height, not the change in the radius. This is the change. These are the rates. Got to get that difference there. What is the rate of change of the volume V of t of the cylinder at that instant? So we're going to be looking for V prime of t at that moment, at that t0. So let's look at what's given. Did they give us r of t? They gave us the radius. The radius is always changing, so we need the radius at that moment. And the radius at that moment was given right here. At that certain time, the radius was 5. And then they also gave us that the height was 8. Well, we're looking at h prime though, so dh dt, negative 4. You can see they're interchanging the notation there. Both mean the same thing. dv dt, which is v prime of t naught, is going to be not given. That's what we're looking for in this problem.